Now we're going to talk about how you simplify fractions. Usually in math, it's just easier to work with simplified fractions. The numbers are smaller, and it's just the numbers are nicer. And so we prefer to work with simplified fractions. So what we're going to talk about is how do you go about doing that? And I'm sure you've probably learned different methods, but I'm just going to show you one way that branches off of something you already know how to do. It's always easier to learn a new concept if it's just like a little bit different than a concept you already know. So I'm going to use factor trees because we've already covered factor trees pretty extensively in here. So a rational number a over b is in simplest form if a and b are relatively prime. So if you remember from a previous chapter, relatively prime means they don't have any factors in common other than 1. Their greatest common divisor between the two numbers a and b is 1. So like 2 and 9 or 3 and 4, these are numbers that don't have any factors in common. So to start off, I think it's easier to use factor trees, and then we're going to go in and cancel. I think it's going to make the math really nice. So I went ahead and did the factor tree for 64 and 300. You can do, your factor tree might look different, but we should all end up with the same circled prime numbers at the end. So the way that I'm going to write 64 is I can see that it's 1, 2, 3, 4, 5. It's 6 2's. So I'm going to write it like this: 1, 2, 3, 4, 5, 6 2's. That's my factor tree, my prime factorization for 64. And then for 300, I have, remember you want to write them from low to high. I have 2 2's, and then I have a 3, and then I have 2 5's. Like that. And what you want to do is go through, and we're basically going to do the reverse of the fundamental law of fractions. So if you can find two numbers that are the same on the top and the bottom, where the only thing we have going on in here is multiplication, like this. Well, what is 2 divided by 2? Well, 2 divided by 2 is 1. And then here, what's 2 divided by 2? 2 divided by 2 is 1. So those turn into 1's, and when you multiply by 1, you retain the number's identity. So it's almost like we can ignore those. That's why people have told you they cancel all these years. And then what you're left with, you can see there are no common factors on the top and the bottom, so you're done and it's simplified. You just have to like multiply it out and make it look nice. So 2 times 2 times 2 times 2 is 16, and 3 times 5 times 5 is 75. So 16 over 75 would be the simplified fraction. They don't have any factors in common. Now let's try 36 over 144. So for these, I am going to do a factor tree. So let's see, for 36, 36 is 6 times 6, and each of those is a 2 times 3. So for the top, I have 2 times 2 times 3 times 3. That's 36. And then for 144, 144 is actually 12 times 12. That's a perfect square. And 12 is 2 times 6. We could do it that way. And 6 is 2 times 3. And then we're going to see that again over here. Like that. So we have 1, 2, 3, 4 2's, and then we have a couple 3's in there. Make my fraction bar a little longer, and then we're going to look for the commonalities here. So there, that's equal to 1. 2 over 2, that's equal to 1. Oh, bear with me here. I didn't really line things up nice. We do have a 3 divided by 3 that's going to be equal to 1, and another 3 divided by 3. Those are also going to equal to 1. So the reason why I like to do it this way is because you notice what's left on the top is not nothing. What's left on the top is actually 1. And underneath, you just have a 2 times 2 that's left. So that would be 1/4. So it turns out that 36 divided by 144 is the same thing as 1/4. All right, let's try some more examples here. Now we are going to start to see some variables, right? So this is kind of leaping into the algebra of it all. So we have 30 times x times y squared, and then we have 16 times x squared times y. So let me just worry about the numbers for right now. So let me look at 30 and 30 happens to be 3 times 10, and 10 is 2 times 5. And then 16 is 2 times 8, and 8 is 2 times 4, and 4 is 2 times 2. Okay, so I'm going to string out my numbers first. So 30 is 2 times 3 times 5. And then 16 is, there's 4 2's. So 2 times 2 times 2 times 2. And I'm going to play the same game with my x's and my y's. So on the top I have an x. And then for y squared, I'm going to write it as y times y. And underneath for x squared, I'm going to write it as x times x. And then I have a single y. And how we circled and then said, oh, if you have a number over itself, it's equal to 1, you can do the same thing with variables. So here we have 2 over 2, that's 1. We also have x over x, that's 1. We also have a y over y, and that's equal to 1. And so we just kind of cancel things out the same way that we did before. If it works with numbers, it also works with letters. So we're going to end up with 15 and a y on the top, and what is this going to be? 8x on the bottom. And you notice 15 and 8 don't have any common factors. They're what we call relatively prime. So 15y over 8x, that would be the simplified version of that fraction. Now the next one has got, it's a little bit more like factoring. So you see on the top we have a 3a plus 3b. So the a and the b are both multiplied by a 3. And underneath we have a plus b times a minus b. So this bottom part is already factored out. The way you would factor out the top is if you see with addition or subtraction, when you see that you have something common, you're allowed to simplify by pulling it out to the front. So instead of writing the 3 twice, I'm just going to write the 3 once and say that it was distributed to the a and the b. So we are like undistributing. That's what factoring is. So instead of writing the 3 twice, you can get away with just writing it once. That's a simpler way to write it. And then underneath we had an a plus b and an a minus b. Now this little canceling and one trick that we did only works if you have multiplication. So this a plus b, see how that's addition? That whole chunk needs to be all kept together. You can't break it apart. So it's all or nothing with parentheses. You cancel the whole parenthesis chunk or you don't get to cancel it at all. You can't go inside and individually cancel things inside parentheses. So you'll notice we have an a plus b on the top and we have an a plus b on the bottom. So just like we had before, a plus b over a plus b, that whole thing cancels and becomes a 1. So what we're left with on the top is just 3 times 1, right, 3. And on the bottom what we're left with is the a minus b. But be very careful when you start getting parentheses involved, it's all or nothing as far as canceling goes. Let's try one more. We've got 5a plus 10 over 10. And we cannot cancel the 10 over 10 because we have addition. See, it doesn't look like the previous ones where it was all multiplication. So you've got to do some factoring. So if we look at the top has a 5 and a 10. The common factor that they have is a 5 because 10 is 5 times 2. And this first piece is 5 times a. So they both have a 5 in them. So I am undistributing the 5. I'm undistributing it. See, if you distribute it back in there, you get a 5a plus 10. I'm just taking that 5 out. Now, underneath, I'm going to write the 10 as 5 times 2. Or 2 times 5, either way. Okay. And the reason I want to do that is because, see that 5 over 5? 5 divided by 5 is 1. I'm not going to go inside my parentheses and cancel the 2's. I can't do that because, remember, with parentheses, it's all or nothing. So what I'm left with is actually a plus 2 on the top and 2 on the bottom. The most common mistake I see here is students try to cancel the 2's. You can't do that when parentheses are involved. The other mistake I see is right here at the beginning, students will try to cancel the 10's, and that's just not a possibility. So these last two examples, D and F, I guess that should be an E, shouldn't it? That should be example E. If I knew my alphabet, it would be awesome. So anyway, on these two examples where there's addition, you have to work a little bit differently. You have to think about factoring, and then when you cancel, it's like an entire parenthesis chunk or nothing at all, right? Like we had here in D. Here we just had a number that canceled like all the other ones did. But you got to be careful on those that contain addition.